It is really so great to be here, I can't tell you. I just, like everyone else. Like everyone else, I just want to say thanks to Ben and Matthew for all the effort that they put into organizing the event and for inviting Anton and I to speak for you today. My name's Nick, and you can probably tell from my accent that I'm not from Vancouver. I'm from the deep south. And although Sydney is a great place to live, it is quite far away from almost everywhere. Around 12,500 kilometers from where we're standing right now, which ChatGPT tells me is about 77,000 miles. So I only got in this morning, and it was a 15-hour flight, and I will be honest with you, I slept about as well as a Windows laptop. So. Another fun fact, you might notice I actually left Sydney Airport after the conference started. So in true Handmade style, I technically exploited an overflow in the global time zone logic in order to get here. But yeah, a few people were surprised that Anton and I were working together on something. Handmade projects tend to be a bit lone wolfy. Ben certainly was surprised. Because he actually had sent Anton and I two separate individual invitations to speak here about two different projects. And when Anton and I got these messages, we were like, yeah, we decided to buck up and do it. And he responded about how you would expect, yeah. So yes, the cat is out of the bag. Anton and I are working on a game, and it is an RTS. It's a real-time strategy game. We chose to do an RTS because for our first project, we wanted a genre that was really popular and relevant with modern audiences to maximize our chances of financial success. One thing is not true about this, though, which is that it's no longer untitled. So it does have a name. And instead of just telling you what it is, I'm just going to launch the game. I'm going to compile it and launch it, which is true danger zone, but we'll give it a go. So, INSTRUCTOBOTS is the name of a fictional line of 1980s miniature figurines that you play in a tabletop game, kind of like Warhammer 40,000, if you ever played that kind of thing. The difference in our universe is that, with alternate technology, these miniatures have tiny servos and batteries inside them, so they can actually move around on their own rather than you having to move them. So it's, one of my sort of childhood fantasies. But to see how that translates into a video game, I'm just going to walk you through a couple levels of the tutorial. You can see how the game kind of works. So typical three-race setup. The commandos are kind of like Terran from StarCraft. So we're just going to launch the tutorial. And, very standard RTS setup. So you can imagine I've got my soldiers over here, some evil bugs that I have to destroy. So I'm just gonna, oh yes, we don't have box select, sorry. So I'll just select one of these guys and right click. Nothing happens. Okay. So the bugs are moving and they're coming to attack my guys, but I can't seem to actually do anything. And this is where I have to admit to you that we haven't actually been entirely honest about what this game is. So in the universe of our game, I mentioned that the figurines can move around on their own. Well, the way that the player controls them is that you boot up your 1980s personal computer, you launch the INSTRUCTOBOTS terminal, and you write a program, and then you flash the program on to the figurines, so they can move around and make decisions autonomously. Surprise, it's a programming game. So we're going to just edit the program for our soldiers, and we're going to do something incredibly rudimentary for the first level of the tutorial. We'll just say start attacking, and we'll pick the closest visible enemy. We'll rerun the battle, and you can see that our guys are now shooting, and we beat the level quite easily, so we'll just continue on to the next level of the tutorial. Okay, so we lost on the second level. We'll have a look here. So our guys are just trying to shoot on a loop because we're telling them to start attacking. But can anyone see what's happening now? So if I select the Scorpion, you can see that its attack range is overlaid as this red circle on the terrain. And this is also a good opportunity for me to point out the replay controls at the bottom here. So the way that this works is you take your army to, a hobby shop, that type of thing, and you do a battle and you tape it on your handy cam, and then you bring the tapes back home and you can review them. So we can rewind the battle and watch our guys come back to life, pause it, or scrub the entire thing in real time if we want to. So back here you can see if I select one of these soldiers, we're just barely out of range. So the Scorpion outranges our guys, which means we're probably going to have to not just shoot, but try moving as well. So I'm just going to edit the program again. Sorry, I'll zoom in here a little. So we're just going to say start moving, and we'll go towards closest visible enemy. Super dumb, but it should probably work. So now they're doing this like weird stutter stepping thing. But it still gets the job done, So the reason that they're doing that, we'll just open this little picture-in-picture debugger here. You can see that the programs just go on loop. So they're just going move, attack, move, attack, move, attack around the circle. So this can beat this level, but it's probably not going to get us all that much further. Yeah, so we lost here. And we can observe what's going on. So you can see because they're doing this stutter stepping thing, they're wasting all of this time. They could be attacking, just, getting beaten up instead. So what we probably want to do is do some kind of logic like, if the enemy is outside of my attack range, move towards it, but as soon as it's inside the attack range, just only attack. So in order to do that, we'll do a few more kind of general purpose programming constructs. We'll make an if statement, and we'll say if the distance to the closest visible enemy is greater than the weapon range of this unit. So it's like if it's out of range. Now in a standard IDE, you might cut and paste this. In this terminal, you can press space to just lift an instruction up and move it around. So we can just move it inside the if statement. You can also use the mouse to move this stuff around. The whole interface is drivable with either completely keyboard, completely mouse, or a combination of both. And we want to attack when the enemy is inside our range. So we want the opposite of this conditional, so we can turn this into an else. And we'll move the start attacking inside there. We'll rerun and have a look. So this seems a lot better. They're just standing in place and shooting. Of course, we can watch what they're doing. And we've got a nice time travel debugger here where we can step backwards. So we can beat this level quite easily. We still got 3 guys or so left over, I think, by the end. Yeah, great. So we'll do one more level of the tutorial and then we'll move on. Introduce a few more interesting concepts. So, okay, in this level, this armored beetle has heaps of health, is very slow, and has a melee attack that does a lot of damage. And so it's able to kill all 5 of our guys. Who here knows what the word kiting means? Yeah, okay, great. So we're going to try and implement a kiting program, which is basically, because we can move faster than the enemy and we have longer range, when they get close to us, we want to run away, and when they're further away, we want to shoot at them. So we'll probably do it by actually using some variable stuff. So this is essentially just a very, very, very complex instruction set. It's basically assembly, but it's Turing complete. So you could probably write Doom in here if you're a masochist. So we'll say kite range, and it's got a type system number. What I'm going to do is I'm going to assign kite range to the unit's weapon range, and then I'm going to divide it by 3. So I'll say, like, if they get within a third of my weapon range, then I'm going to run away. So this first condition will still fine. If they're outside the weapon range, we want to move towards them. But inside this else, we probably want another if. And we'll say if the distance to the closest visible enemy is less than the kite range, we'll start moving instead away from the closest visible enemy. And we can turn this into an else and put start attacking inside there. Get the general gist. So let's see how it pans out. Works pretty well, hey. So you notice they're not all moving at the same time, and it's because they all have different instances of the same program. So they're all running autonomously. It's basically like a distributed system problem. I think I didn't lose a single one. Hell yeah. So instead of spoiling the rest of the tutorial, if you want to give it a play later, obviously the main sort of thrust that we're going with this is like online multiplayer. And similar to Warhammer, you will be able to like build your army up to a points total, and then, I've got a bunch of armies that I was making here for random stuff, and you can customize their equipment. You can assign a unique program to every single unit in your army if you want to. So we're hoping that there's a reasonable amount of depth to be had here, and it's been a lot of fun working on it already. And I'm going to hand over to Anton, and he's going to tell you a bit about the process of us actually working on it and how the technology works. Oh, sorry. I'm just going to unplug this.
So my talk's going to be a little less technical, still a little bit technical, but mostly focus on like Nick said, not a lot of the handmade projects often get together, and how do you actually ship these things, and how do you, we've been working on this for what, like 4 months full tilt, maybe 6 months total. So, like how do you actually get out of that noodling stage and into something that starts to resemble a game, not shippable yet, but at least you can demo it at an event or something like that. So I've been doing a lot of side projects for a long time. Average about 3 per year for 20 years, so it's like 60 something. So I have like just sort of been collecting health packs for a while. Like I'm gonna need this someday, and then I will apply it. So like now I'm applying it. So when Nick and I first started talking about it, I was like, hey, Nick, we just do like a simple 2D programming puzzle game. I got this project that I abandoned/shelved like a year ago. And he's like, yeah, that's pretty cool, but how about we do like combat instead of puzzle? And I was like, yeah, okay, cool, but still 2D, right? And Nick's like very persuasive. He's like, yeah, but 3D would be cooler though, wouldn't it? Like, because 3D. It's the first rule of like indie game dev is that you don't do a 3D game. Like, just don't do it. You can't do the art. There's a lot of stuff. You think it's easy. You put a cube and you're like, I'm almost there. You're not almost there. Don't do it, right? So I was like, okay, Nick, who's Nick? He's like, you shipped a game before this. He must know that this is a bad idea. But I still can't quite tell if he's like optimistic or just doesn't know. So I was like, all right, but we do OpenGL. And he's like, deal. Okay. So why OpenGL though? Because like we're all real graphics programmers here, but we need Mac and Linux or Windows and maybe Linux. I don't know. I'm like a solo graphics programmer. I'm more of a graphics programmer adjacent person. Like I know the graphics, but graphics is a full-time job, and I have other jobs I need to do here, like make the assets. But we're doing a PS1 aesthetic, so like, do we really need Vulkan? Do we need compute shaders? Like, really? I think we'll be all right. So the reasons are, basically, I know it well. I've got 20 years of just OpenGL code strewn around. I can just grab bits. It'll be fast. Mac OS supports OpenGL 4.1. They just locked on it. They deprecated it, but the chances of them really getting rid of it, pretty low. If you're watching this, Apple, do not do it before we launch. It doesn't have compute. There's no image read-write. There's no multi-draw. Sad. But no problem. These are constraints. We don't need that. And PS1 didn't have that either, right? And they shipped. So should be fine. Windows is stable in terms of OpenGL. The reason I know that is because I filed an OpenGL GLSL compiler bug, and NVIDIA said won't fix. I'm not doing it anymore. So I'm like, oh yeah, that's good. It's stable. The bug's still there. So I don't anticipate things changing. And there's the shader toy gold mine of like, all the GLSL code you'd ever want. And like I said, 20 years of code that I have. I do have some experience with Vulkan. We can do a Vulkan rant later. We did not do Vulkan. I've done Vulkan. We did not do Vulkan. Let's leave it at that. OK, the other options, right? Why don't we just do DX11 on Windows? That's like pretty cool, but Nick's on Mac. So all right, we're doing Mac. Vulkan, yeah, you get Windows and Linux, but Mac OS, you go through Molten VK, which is like kind of, I'm sure it works, but I've heard horror stories. And I'm like, the last thing I need is like bugs from Molten VK as part of our indie project. So just like, let's not do it. SDL GPU looked really tempting, but the shader pipeline is like much more complicated for a modern thing. There's lots of this binding, transliteration. But like if we ever want more things, that's probably our best bet, or like BGFX or Circle or something like that. So for another day. OK, right. Time to scavenge. We need a lot of stuff. So we need math. I have some math. I wrote a math library. It's actually a generated math library. It's mostly tested. It's open source. Don't use it. The cross product is reversed in the open source version. I fixed it, but I haven't pushed because it's years ago. So don't use my code. But I fixed it, so it's fine, totally fine. Write your own math library is not an issue at all. RNG and noise, very important. We cross-compile that to CPU and GPU, so anything that runs on CPU for random procedural stuff, we can just dump on the GPU. Again, we gotta go fast, Shader hot reload those shaders. Backwards compatible rasterizer, serializer, I mean, talk about that. We have good enough performance ECS, not an ECS data structure. You can watch the WooCast stream. It's from that, more or less. I accumulated robust OpenGL error reporting over all the years of OpenGL failures, and you need that on Mac, because Mac is really careful about their OpenGL and just piles of code. So we have font, things of that nature. OK, and let's just make a real quick render. Just one more. Super simple, like for real this time. More like a wrapper, like an RHI kind of layer or something. You just have render target, texture, vertex, buffer, texture, buffer at the end. And then you can clear those things. It's kind of immediate mode-ish. So you sort of say, I want a render target that's like this. And you give it the resolution. If the screen pulls apart, it just says, oh, the screen resolution is different. I better reallocate everything. So like the whole renderer just rebuilds live, more or less. So that prevents all the bugs with resizing and things of that nature. And basically, this is a hedge against OpenGL. So it's a thin wrapper over the stuff we can do. And if we ever want to switch things to something else, we can do that under the hood. It's about 1.3K lines. Quick and dirty. Graphics on top of that. We need some kind of vertex buffery thing. Nick needs to render clay. Let's build that really quick. So rather than building a graphics library, make a vertex buffer builder. Add things as we need them. Don't add things as we don't need them, because that way lies foreverville. Just one format for all of 2D, just one shader, position, vertex coordinate, and bits. You can do lots of funny things with bits. We have bits per vertex. There's 32 of them. You can put whatever you want. The world's your oyster. Like you can. And this code's really boring to write, so you gotta get your lulz somewhere. This is your own code base, so have fun. 3D, we need 3D stuff for like, just rendering quads and things in various places. Just copy paste the 2D, add another thing. It's almost the same. A bit after I wrote this, like Arseni's talk came out with Mesh Optimizer, and I see him in the back like, wait a minute, that's a Vec3 normal. That's full 3, Vec3, like float 32 times 3, and it was considered the awfulest option. It's supposed to go half, but I have a new one for you, Arseni, which you haven't seen before. You've seen Vec3. Have you seen Vec4 for normals? Because that's our gbuffer format. We have an alpha channel on our normal maps because when I debug them, it's nice to alpha cut them. It's nice, it's handy. The GPU has a lot of memory, especially if you're doing PS1 graphics. PS1 graphics also don't need AA. AA is really hard. There's like TAA, all kinds of AA, DLSA. Don't need it, we don't need it, because PS1. It's within my abilities to hand model 3D graphics. I modeled all the bugs and the marines and whatever in there, so it's all right. And it's hard to make it slow even if you try, and I'm trying clearly. But you just throw a lot at a modern GPU and it'll do it. Texture management, just one atlas for everything. Huge 2K texture, holds like hundreds of models from the PS1 era, beautiful. Vertex vertex buffer is like 100 megs. All the vertices go in there. It's instanced only, so if there's one, there's many. So there's just like, we never draw one of anything, you just have a bunch of instances. And then you just slap some modern effects on top of it to kind of, bring it and zhuzh it up a little bit. No one really likes real PS1 anymore, I think, let's be real. So Nick's like, great, well done, I'm feeling good. 3D render speed run, it was like a month or something. Okay, but animation. I've never done animation in my stuff, so I kind of vaguely know, like you put the matrices in there and you multiply the matrices by the things, and they come out of the file somehow, and I think FBX is what professionals use, so let's write an FBX importer. Oh God, abort, do not write an FBX importer. We're not doing that. Okay, fall back to GLTF. There's CGLTF, which is a really nice library to load GLTF data, turns out. And here I'm like, okay, we need animations. I gave in to the urges, and I was like, Claude, show me how I write CGLTF animation. And I was like, it doesn't look so bad. Like, look, it loaded the file, the thing in the vertex bucket. And then I'm looking closer, I'm like, wait a minute. Once you actually start reading the code and you actually know something about animation, you're like, the traversal order is really odd. Like, it's going into the animation, then it's kind of popping back out to the shape primitive, and it's doing funny Alex, it's duplicating code. Okay, rewrite it all, obviously. But it's actually really nice to see the API in use, because it's like generating the example code and being like, wow, this is not good, but at least I know what the API functions are called. And then you can rearrange it into something. So, okay, it took about a week to get like a bendy stick, which is like your hello world of animation. If you're gonna do it yourself, basically my only tip is slow and steady. It's gonna get nasty. You're gonna open inverts, are gonna go crazy. Just don't flip out, stay focused. Don't flip signs like Claude would. Don't just sort of say, oh, this matrix should probably be a transpose. It shouldn't be. But GLTF spec has some really funky stuff in it. So Claude did point some of that out. Like, apparently the root transform of an armature doesn't actually participate in the hierarchy. Okay, whatever. Would have been much worse if things were in a messy state, but they weren't. This is only like 1,000 lines of code. Okay, so from that, we can make immediate mode graphics. We have Asset Manager, just basically loads all the bits, hot reloads them, puts them all in one big fat buffer. You can add instances, reference them by handle within the frame. They only last the frame, and then we throw them away. You can set properties, apply animations. And it's about 2K lines for loading, animation, viewer, debug, everything. So less state, less lines, less cycles. Those are like my 3 go-tos for how to do it. And who wants to type asset? I mean, come on, it's too long. Nick likes long names. I don't like long names. It's easily extensible. I can just add set tint, set opacity, whatever. And the main goal is just to hide the instance packing, because it's like, thanks packing formats. We don't have scalar packing layout because GL 4.1. All right, now we got some models on the screen. The terrain's looking a bit rough though. I wrote a 2D tiling thing before the game was 2D, and I was like, all right, let's reuse it. But then Nick's like, hexes are cool. I was like, yeah, hexes are cool. Okay, so Einstein lattice is like a triangle, skew, really nice coordinates. Let's just do that. So throw some triangles, use the noise library. It's nice, it's on CPU, GPU, same code. Shaders can like replicate the terrain if they need to in the shader, as opposed to just on CPU. 1K lines, generation, doodad, scattering for like the rocks, the trees, or whatever, sampling, rendering, job done. ThingDB, I'll probably skip most of this. There's a WooCache podcast about it. It's basically our thing entity system. It's just things in a pile. It's a slot map, our machinery style, there's no allocations. Stable weakref semantics if you're into that sort of verbiage. It's fast enough. We're not going to have that many things, so it'll be good. And you can do some nice, simple filtered iterators via Bistmaster. You could just say, like, iterate all the collidables, iterate all the renderables, and it just brute force sweeps the whole array, and it's fine. It's not that much stuff in there. One nice thing is we have clear rules about what happens when you add or remove or do anything during iteration, because like the canonical problems, like you shoot a rocket, the rocket appends to the end of your array, and then your update loop updates your rocket, even though it appeared on this first frame. But if you have holes, maybe the rocket appeared in an earlier slot, so it didn't update. So we solve that, and we make sure that basically things don't get touched on the same frame. Serialization, I mentioned it's like Little Big Planet Dream style. So it's macros, define what gets serialized. It supports versions, so you tag things with a version, and it will automatically sort of do the right thing. It's binary, there's pros and cons to that, but for like game data, it's good. And all of the replay scrubbing works off that. We just serialize and deserialize, so it's nice and fast. There's no overhead. It's kind of interesting. You can read up about the Little Big Planet serialization method. It's unique in the sense there's no typing or strings of anything in the file. It's literally just the data, truly no other data. So 400 lines, easy. And there's an interesting combo potential with memory arenas that Nick wrote. So if you're interested in memory arenas and serialization, go talk to Nick. There's some cool stuff. Clay for UI. It's awesome. Watch Nick's presentation of how it works. Only thing worth mentioning for like this particular implementation, took a few hours on top of our sweet graphics layer. And it's a single draw call even for scissor reasons because we have that magic bit thing, so we can like scissor stuff as we go. Not efficient, but single draw call, simple. Works, no notes, nice. Programming editor, it's secret, lol, have to talk to Nick. I have to invite him again next year. He can talk about the programming editor. But it's 1.4K lines, not very big, but pulls a lot of weight. Like you showed, you can reorder things. It's all runs on Clay, has the animation stuff. Nick had to upgrade the animations in Clay to handle it, but he did. Okay, so with all that in mind, so you want to be a handmade hero. It's not hard, it's not easy either though. It's kind of in between, it's possible. Both Nick and I have jobs and kids. So you can still do it even with that. Our approach that seems to be working, don't sue us. About 80-20 ratio of familiar versus new code is kind of what you want to do if you want to actually do the game bit. If you want to learn, that's totally fine. But basically the familiar code gives you like stability and confidence to sort of get progress easy, like you get easy wins. And the new code keeps things motivating. If you're just doing the things that you know, you get bored and then you just want to learn about something. Like that's why you start a new project. You're like, I know this, I want to start a new project to do a new thing. So you got to give yourself enough of that stuff. But if you want to ship, mostly stick to stuff. So like the trick is, take your projects, whatever you have, take that pool and be like, what can I make with it? Use those as constraints. Oh, I have serialization and textures. What can I do with that, right? Like, and then add one new thing or something. There we go. So this is the science. This is the best I can kind of come up with. So like, it's something like ownership of the code gives you familiarity over the code, and patience gives you the learning muscle. And then the learning is what gives you the motivation, and the constraint is what gives you the focus. And those are your primary resources and kind of how to get them. And then you combine them into these derived resources. If you have familiarity and focus, you get velocity. If it's code that you understand really well, and you have a very particular thing you want to do with it, you can go fast on that axis. As soon as you lose focus or familiarity, you're sort of hosed. And focus and motivation gets you that momentum feeling of like, I am having fun with this, I want to keep doing it, it's enjoyable. If you lose focus, you're like, maybe I'll do this other thing again. And you need momentum to get through these slogs of like, you just got to grind out the animation system or whatever, right? And the patience is what you need to avoid these gumption traps if you read Zen and the Art of Motorcycle Mates. It's a good book. Acceleration is negative. You just got to focus and be like, okay, I'm not going to just randomly flip signs. I'm going to do this correctly. You need that to get through some of these traps, otherwise they'll sink you. And the other person works a bit like a momentum capacitor. Like if you're in a down state, but they're making cool stuff, you're like, great. So you get some vicarious motivation, they'll maybe carry you through. And the obligation improves a bit of focus. So if you're like, oh, should I noodle this? I'm like, oh no, actually Nick's waiting for the scissor region. Like I should probably do the scissor region. So with that in mind, consider that copy-paste, excessive libraries, LLMs all remove ownership, they degrade patience, and give a false sense of not requiring constraints. That's like top line. That's what starts to sink things, and so on and so forth. If you lose familiarity, you lose confidence, you lose patience, you lose learning. That screws up motivation. So all this stuff cascades into this feeling of like, I've done a lot, but I don't feel like I got anywhere really. And you can kind of trace it back and be like, what's kind of missing here? And when you lose your motivation, you start to want to replace things with like quick results and like bursts of short-term progress that like get you going again, but then you're like, oh, I don't know, it's slow again. So you need that bit. So the prescription, 80% code from the past, pull whatever you got, 20% new stuff, have fun with it, and then use constraints to call out the work. Culling out the work is better than having a library to do the work, because the library is like just giving you a false sense of how big you can build. And own is better than good, so it gives you those resources. So even though it's not good, it's helping you mentally through this process. And then you can use the formulas to get desired results, and then less state, less lines, less cycles. Thank you. Thanks. So you can scan that to get on the Discord, or you can come talk to us. We'll have a Discord for the game. You can play it, and then we take questions. Now, if there's time, I don't know.
Yes, there is time. We're going to allow questions. Okay, so that was a great presentation. So who wants to take the first question? Oh, I see Cameron back there.
Double-clicking onto the science piece of your slide, how much does like you guys being in different time zones and located physically different kind of factor into all of that?
That's a good question. Like, we're not located physically. We actually just first met in person today. So it's kind of cool as like an experiment, because it's like, at least for what it's worth, physically dislocated. We sort of met on Twitter-ish. We both have families and other obligations. So we can do it part-time remotely without cross-corollary connections. I don't know what the chances of that are, but it is feasible. That's all I'm going to say. But it does help that, like, when I go to sleep, I wake up and Nick's made something, and when he goes to sleep, I wake. So there's this like cadence of you wake up to progress, no pressure, progress. We need progress. So yeah, I think that does help, but I think it would be good in person too. I don't know. I think it would. If you had a choice, would you rather work in an in-person studio? Probably.
I'm a very in-person kind of guy. I don't know if you can tell. I've found that there's just incidental stuff that really adds up, that never gets written down by anyone ever. It ends up just like adding up to this shared context that you really need to move really quickly. Like for Anton and I, one of the things that allows us to actually move quickly on the project, I think, is that you can probably tell from the presentation, like this is literally Parkinson's law in action, right? We tend to do like quite different pieces that we've agreed upon some small sort of interface where they're going to meet, and we work on them separately. But in order to do that, we really have to trust each other, and a lot of trust comes from the shared context. So it's like we do work remotely, but we have like a gargantuan Discord chat of like all the most random stuff.
Right. Right. Like we didn't coordinate the presentation. I've never seen Nick's presentation. He's never seen my presentation.
It's a surprise. Yeah.
Yeah. But yeah, like with the code as well. Like there's a lot of talk, especially like in corporate world, of like reducing buzz factor, and like, oh my God, what happens? It's like our mentality is like, well, if Nick leaves, it's like a band. It's like, if someone leaves from the Beatles, it's like, how do you keep, it's like, no, there's just no more Beatles. So just accept that as the reality. The buzz factor is what it is. Most of the code Nick wrote, I don't know how it works. But because there's a general, like, value system sharing, like handmade style, I'm not terribly scared. Like, I can go in there and like figure it out if I have to, right? But the velocity comes from not having to have to.
I don't know, this Paul McCartney guy has really low buzz factor. Like, we need some duplicate McCartneys.
Right.
All right, next question, Felix.
So that looked wonderful. It seems like there's so much UI and sound polish, especially for what seems like a pretty early stage. So first of all, how do you decide what things should, like, how do you get inspiration? So I noticed that the fading on the buttons when you hover over is like a lower frame rate than, like.
It's quantized color, yeah.
Okay.
Happy accident.
So this is the whole thing. All of it comes from constraints. So essentially, both of us really believe that you can't make good art without good constraints. If you allow people to do anything, they come up with something terrible, right? They need a box to fill. And so for the look and feel of the game, we knew, like, we don't have a professional artist on our team, right? Which means that we need to lean on other things, including like full screen post-processing, like really, stylized user interface stuff, that kind of thing. So we're like, that sort of informed us as like, what kind of aesthetic can we go for? And then as soon as we got to like the CRT kind of effect, I was like testing colors in the UI and I'm like, whoa, I can only get like 4 bits of color depth.
Because I quantized the color before to make it look better.
But as soon as I had 4 bits of color depth, I'm like, cool, I can only use 4 colors in the whole UI, and I got to make it work with only 4 colors.
Shades even, right?
Yes.
Not even colors, shades, yeah.
Yes. Well, yes, literally four shades of a monochrome. So as soon as you do that kind of stuff, you come up with these effects like, what happens if I transition from the darkest color to the lightest one? I get this stepped quantized effect from one to the other. And so you get that kind of stuff just falling automatically out of the constraints. And the most important thing is just to lean into the coolness of the constraints rather than be like, this is unacceptable. It needs to be 240 FPS, smooth color transition. So yeah, like a lot of it comes from that.
Did you make the sounds?
Yeah, I'm a guitarist, so yeah.
All right, next question.
I'm curious how you guys designed the programming language API. Like you have the towards and the shoot and all that stuff. Like how do you teach that to a new player, and then how do you change the API and come up with new functions and stuff like that?
That's a really great question. So in terms of how you teach the new player, you hope that everyone is already a professional programmer before they play the game the first time. It is actually really tricky. And we've had hilarious experiments just giving it to people and being like, try doing something. And they're like, I have no idea what to do or what to click. But
we're going to get hundreds of sales. Hundreds.
But the interesting thing is, Anton talks about 80% reuse and 20% new stuff. When you see something like this, you're like, oh, they must have had this cool idea where it's like, I want to do this assembly-like programming language for the editor and stuff like that. I have made, in my life, 10 different assembly-like programming languages. This is one of the iterations of something that I almost have done as a hobby for most of my programming career. And it's just one of those things where after a while you build up this reusable backlog of stuff and then you just think, oh, this is going to work really well here. So for example, we were talking about okay, we want to make programmable units. We could probably go with Lua or drop in maybe a Python interpreter into the game. And as soon as we started thinking about that, the complexity explosion of something like that is just immense. And so we decided to go with something really, really narrow, 1 instruction per line. There's nesting, which gives you the illusion of a structured programming language. But it's basically just like I said, a very complex instruction set.
Complex in the CISC versus RISC way.
Yes,
it's not actually complicated. It's just there's more instructions.
In the technical sense.
Yeah, in the technical sense.
But the cool thing is, when you have constraints like that, it allows you to do stuff that we wouldn't have been able to do easily if we were using something like Python. Like, for example, it's not obvious, but each of the instructions actually has a different time cost. So if you're sitting there thinking, if your unit's sitting there thinking, like running its code instead of shooting, it's going to get killed, right? So different units have different base time costs, that kind of thing. So we're able to like do that. It's trivial because we're just looping through an array, right? But when you think about like, I want to add like a base time cost to like Python expressions and like run them in parallel across, like I don't want to approach doing that type of thing personally. And also on top of that, of course, like we now have a system where when people submit games to be calculated on the server, we don't have to worry about them programming infinite loops or anything like that. If you make an infinite loop in this game, your unit just sits there doing nothing. Because we get to choose how to progress the underlying time slices.
It's time slice by default, yeah.
So it's sort of just like leaning into the constraints that you have set for yourself. You can come up with some really cool combinations of things, I think.
All right, next question.
First, a comment. I think you have created the coolest AI authoring thing I've seen, like gameplay AI authoring thing. It looks a lot like a behavior tree, but like better. And the second thing is, how do you envision the multiplayer going? Because is it going to be like people pre-upload programs for all their units, or is it going to be like back and forth multiple rounds? So I can imagine there's going to be situations where like, oh, I figured out what your program does. Now I'm going to write something really adversarial.
Well, we've found that one of the most enjoyable things to do is get a really nice general purpose army from someone and then just cheese it into oblivion. Like, it's really funny to write like a specific exploit for something that someone's doing. They think they've covered all of these cases, right? Likely we're going to have some kind of, chess-style MMR matchmaking for programs on the server. So you'll submit a program. It will run it against a bunch of things that are similar to your MMR and then give you the results back. We're leaning into this metaphor of like, you take your guys to the hobby shop and you get a bunch of tapes of like what happened and you bring them back and you watch them and you're like, oh, I screwed up because of this. And we also just want to, like with the Discord sort of alpha that we're going to be doing soon, we really want to do this kind of, you just put up a program and say, try and beat these guys that I made. So I don't know how familiar people are with like Warhammer and like how the armies work, but each unit has like a point cost that's modulated by like the equipment that you put on it and stuff like that. And so you just say, I have like a 150 point army. So it's sort of a balancing mechanic. So you just upload something like that and be like, try and beat my 150 point army with your.
So you can share it with friends or
yes.
whatever and
yeah.
play it on your machine. So probably the server, like real ranked multiplayer, that you would not see the program of your replay. So if you played somebody, you got the tape back, you won't see their program, you'll just see the results of their program. But if you're playing with friends, then maybe you choose to share the program for learning purposes. So, because otherwise it's fun to cheese, but probably from a multiplayer perspective, it won't work too well.
All right, next question.
So just to extend that a bit, in Warhammer, you can, after the game at least, see your opponent's list, right? You, in this case, might not necessarily see their program, but you can at least see the list. So do you have anything in plans for like that? And then also, the terrain can have a big effect on what's good and what's not, and what you have to contend with, right? So is it always randomized? Can you and your opponent potentially agree, like, okay, I want to do 100 matches on this map and see how my army does, something like that?
We're getting into over-promising future features territory here.
Yeah.
Terrain makes a gigantic difference. So at the moment, the battles are completely deterministic. They'll always turn out the same way with the same two armies and configuration. And what you find is slight changes in the terrain, especially in like mirror matches where people have picked exactly the same units, it can make a really big difference. And so I imagine it will probably make sense to have like pre-designed terrain and allow people to like develop strategies for particular maps because there are things that are going to make a big difference. We didn't show in the demo, like we're planning to have fog in the game. So it's like At the moment, we focused really early on like, can we make the micro, from an RTS perspective, like enjoyable to program for? Because we figured like that's really the bread and butter of this kind of thing. And as soon as you can really get that working, it's like you start adding scouting and you start adding, strategic positioning and that type of thing. So it's like getting the core pieces working well is usually what we try and do before we expand them outwards. Yeah.
And to your point, I think again, none of this is written, so this is totally speculative. Just the idea, right, is like, if you do simulate a battle with, like, you and I play armies, I get a loss, and then I don't just get a loss, I do get a replay of what your army is and what they did, and you get that full kind of scrubbing click on everything. It's just I don't see how your army arrived at the decisions that it arrived. So I can see what happened and be like, oh, looks like he's kiting, but how is he doing that? I don't know. So I can we'd like to make it so you can iterate against that in sort of in a vacuum. So we're not running your live program, but something like it. So you can kind of have this debugging experience, which seems to be pleasant. And then, anyway, lots of, yeah.
All right, we're running out of time for questions. So I encourage everybody with them to go to their demo table.
Yeah, and get shirts. We have shirts.
And Tim Tams.
And they have T-shirts.
And candy. Shirts and candy at the demo table.
And candy. All right. Thank you very much, everybody, for coming and seeing these presentations. And a reminder that if you want to have a little lightning demo, reach out to me and Ben. And yeah, that will conclude all of our presentations scheduled for the day. Thank you.